All right, so we're going to go ahead and get started with lecture. This is your very first lecture video, which is going to cover two of your Newton assignments. It's going to cover both properties of exponents and also advanced properties of exponents. These two assignments were very closely related, so I'm going to kind of just lump them together and do it as one lecture video, so you have less videos to watch, plus a lot of the material is just super related. So let's jump in. First, we need to know what exponents represent. So exponents represent repeated multiplication. And I'm sorry my pen is so light. I got a new pen, and we'll see if it does a better job. Yes, that looks better. Repeated multiplication. Okay. So whenever you're dealing with an exponent, you have two parts to the exponent or to the number that you're dealing with. Okay, so let's say we have something like 7 to the third power. Okay, our base is the numbers or variables that are being raised to some power. Okay, so we're going to go ahead and say this is the numbers or variables that the exponent is being applied to. Okay, the numbers or variables that the exponent is being applied to. So we could have just one thing that has the exponent, right? Or we could have several things grouped together that have an exponent being applied to it. So in this case, our base is just the 7, right? Here we just have the 7 as our base because it's the only thing that that little 3 exponent is being applied to, okay? And that little 3 we call the power, okay? This is just the exponent. And you may see it several different ways. We may refer to it as the exponent. We may say raised to the power of. So just knowing that the power just means the exponent, which in this case is that little 3 up there. Okay. So remember again, these are our lecture outlines, which you can print off of Blackboard. I really encourage you to print those out and follow along with me so that you can be filling in these notes and getting the examples and the practice so that you can master this when you go to do your homework. All right. All right. So if I want to write an equivalent statement for 7 to the third power, all that's really asking me to do is write out that repeated multiplication. So this would really just be 7 times 7 times 7. Okay. I know for some of you this is really basic, but I want to make sure that I cover some things so that when exponents show up again in the future, we're not completely lost as to what it is we're supposed to do with them. Okay, so if I have something that's written out in standard form and I want to put it in exponential notation, that means I need to count up how many repeated multiplications I have of, excuse me, this base power 5, right? So I have 1, 2, 3, 4, 5, 6, 7 copies of this repeated multiplication. So I could write this as 5 to the 7th power. Okay, and we're just going to leave it like that. Most of the time when we're simplifying, if this exponent is 5, if you have 5 copies or less, we go ahead and multiply it out. If it's something obnoxious like 5 to the 7th power, 5 to the 81st power, we don't multiply that out. We don't need to know what that ridiculous number is, okay? So we'll just leave it in this unsimplified form, okay? All right, so we have a few rules when we're dealing with exponents that help us simplify expressions. So these are the rules we're going to focus on for the purposes of this class. And the first one is when we're multiplying two bases together that have the same base, right? If they have the same base and we're multiplying them, then we can actually add the exponents, okay? So as long as they have the same base and being multiplied together, we just add those exponents. Okay. Now, if I have a base raised to a power, so a to the n raised to the n, so notice we don't see the two bases, we only have one base, then we multiply the powers. So this would be a to the n times n. Okay. All right, and then I want to come over here. When we have a negative exponent moves the base across the fraction line. So the fraction line is what separates the numerator from the denominator. So right now, since I don't have a denominator, my fraction line is really underneath here, right? Because I could write this as a to the negative n over 1. So that negative exponent, to get rid of it, I'm going to move this whole thing down to the denominator. So I'm going to write it as 1 over a to the now positive n. So when you move things across the fraction line, it changes their sign. Okay, so just like this one we just did, if I have something with a negative exponent that happens to be on the bottom of my fraction, I can move it up to the top of my fraction and change the sign. So this would just be a to now the positive n in the numerator. Okay, so when we move things across fraction lines, it changes their sign. That's how we're going to simplify things like this. Okay, I want to be able to use this property that says a to the n power times a to the n power. I know I can add those, but I have to have them being multiplied together, right? So for this one, they're not being multiplied, they're being divided. So what I would like to do is be able to move this a to the m up there so that they're being multiplied. But remember, when we move it, that causes the sign of the exponent to change. So this would give me a to the n times a to the negative m, right? If I move this guy to the top, the sign of its exponent is going to change. So what now I get when I combine these, when I add a positive and a negative, right, it's the same as subtracting. So this is a to the n minus m. So this is kind of a shortcut way of knowing anytime you have the same base on top and bottom, we really can just subtract these exponents, okay? So the one that we're moving up is the one that's going to get subtracted. Does that make sense? All right, a couple more. So an extension of this multiplication, when we have a power raised to a power, is notice here we have more than one base, right? A and B are both bases to this power, to this exponent. So whenever I apply that exponent, I have to apply it to both base numbers. So I would have a to the n and b to the n. So basically it's like I'm distributing this n to the powers of all the bases. Does that make sense? All right, and same thing when it's in fraction form. Because the base is the fraction a over b, then that n needs to be applied to the top of the fraction and to the bottom of the fraction. So this would give me a to the n over b to the n. So these are all the properties. Now I'm not going to give you a problem on the exam that's like state this property. Okay, that's not how I want you to utilize them. I just want you to understand these rules so that you can apply them in your own problem. Okay, so let's go ahead and look at a few examples using these exponent rules. So this first one, notice I have t to the 5th times t to the 8th power. So same bases. So when I have the same bases being multiplied together, I can do what with their exponents? Well, according to this first property, I can add them, right? So this gives me t to the 5th plus 8, right? And 5 plus 8 is 13. So this gives me t to the 13 power. Okay, so far so good. Let's look at this next one. I have t to the 13 over t to the 3rd. So same base on top and bottom, right? So we have this property that says when we have the same base on top and bottom, we can subtract their exponents, right? Or subtract the exponent from the bottom. So this is going to give me x to the 13 minus 3, because when I bring this x cubed up to the top, it's going to change the sign of it, right, and become a negative 3. So when I subtract those, I end up with x to the 10th power. So far, so good? Okay, let's look at a couple more. Here I have a base with a power raised to another power. Okay, I don't have two bases, so I'm not adding. When I have a power raised to a power, we multiply. So this gives me b to the 4 times 3, right? Which is just b to the 12th power. Good. All right, next one we have p to the negative 11 times p to the negative 7. Because we have p times p and those are the same bases, we can just add their exponents. So this gives me p to the negative 11 plus negative 7, right? So when we add those exponents, what we end up with is p to the negative 18. Right? But we never want to leave our answers with unsimplified exponents. So here, because we have a negative exponent and we know how to get rid of negatives, we want to go ahead and simplify that. Okay, so again, remember this is like a fraction because I can write it over 1. Right now my negative exponent is in the top of the fraction, so I'm just going to take this whole piece and move it down. Okay, So I'll end up with 1 over p to the now positive 18. And we just leave it like that. Not too bad, maybe? All right, let's look at a few more on page 2 here, using these same properties, but maybe a little bit more advanced examples. So same thing here. When I have a fraction, I know I can subtract their exponents as long as the bases are the same. So I can write this as z to the 3 minus 17, right? The one from the denominator, when I move it up, becomes negative. 3 minus 17 gives me z to the negative 14th power. And anytime I have a negative exponent, I want to make sure I simplify it by moving it across the fraction line. So right now it's on the top, right, of the fraction line because I can write this over 1. So I want to move it down. So this gives me 1 over z to the now positive 14. Everybody okay? All right, let's look at the next one. Here again, I have more than one base that this power is being applied to, and so I need to distribute that power of 2 to both bases. Now, when I just say distribute, it is a power. I can only distribute powers to powers or exponents to exponents. So I'm not doing 2 times 3. I have to think about what is the exponent on that 3. So the exponent on that 3 is a little bitty 1. Right? Whoops, which you can't see because I didn't draw it very well. There we go. So that is what I'm distributing this 2 to. So 3 to the first power is now going to become 3 squared because 2 times 1 is 2, right? And then y to the third power is now going to become y to the 6th power because 3 times 2 is 6. And then the last thing we have to do is simplify our number part. So 3 squared is 9, so this gives us 9y to the 6th. And we just leave it like that. Okay. Let's look at another one. Let's look at this one. So on this one, I want to do some simplifying. The first thing I want to do, excuse me, is I want to write it all as one fraction instead of as a fraction times another expression. Okay. So remember, this is kind of like this piece over 1. And with fractions, we multiply straight across. So when I multiply straight across, I multiply tops with tops and bottoms with bottoms, right? So on top, I have 4 times negative 6 u to the 7th v cubed. So the only thing I can really multiply together is the 4 and the negative 6. So that's going to give me a negative 24 u to the 7th v to the 3rd all over u v to the 4th. Excuse me. All right, and now I want to use my properties to get rid of the fraction. So notice I have u's on top and bottom, and I have v's on top and bottom. So I can use that subtraction rule again, okay? So I'm going to come down here. So I have negative 24. When I subtract the powers from the u's, the top power is a 7. So I have u to the 7 minus the exponent from the denominator, which is 1, right? Because I only have one u there. And then my v's, I have the power that was on top, which is 3, minus the power from the bottom. So 3 minus 4. So this gives me negative 24 u to the 6, v to the negative 1, right? And I'm almost done. I'm not done yet because I still have a negative exponent. So I need to take this one that has the negative exponent and move it down to the denominator so that I can end up with a positive exponent. Okay, so when it's all said and done, I'll have negative 24 v to the 6th, sorry, u to the 6th, my bad, u to the 6th, and then that v to the negative 1, I move down to the bottom. When I move it down to the bottom, it becomes v to the positive 1, and I'm not going to write the 1. If you write the 1, that's fine, but usually if the exponent is a 1, we just don't write it. So we're going to leave it like that. Everybody okay? That was a little bit tricky. All right, I got 2 more to do, and then we're going to let you practice them, okay? So on this one, same idea. I don't have anything that I can simplify inside this parenthesis, so I'm going to go ahead and begin distributing this 2 to everything's exponent. So the exponent on the 4 here is a 1. If you have to write it in, write it in. Don't tell me that 2 distributed to the 4 gives you an 8, because we're distributing to exponents, okay? All right, so this is going to give me 4 squared x to the, Again, multiply exponent. So 7 times 2 gives me 14. All over y to the, when I distribute this 2 down to the 6th, I'm going to get y to the 12th. Okay. And then the only thing I have to do to simplify this one is write my 4 squared in a simplified form. So that gives me 16x to the 14th over y squared. And I just leave it like that. All right, one more, and then you get to tackle some of these. All right, so on this next one, I see a lot of negative exponents, but I'm not going to worry about that just yet because I have another negative exponent outside that I'm going to be applying to everything in these parentheses. So I'm going to be distributing this -2 to all these exponents in this problem, right? So d to the -2, when I do -2 times -2, that's going to give me d to the +4. When I do f to the -6 and I distribute that -2 to the -6, I'll end up with f to the +12. And on bottom, g to the -3, when I distribute -2 to -3, I end up with g to the +6. And notice what happened because we're doing negatives times negatives, all of our exponents ended up positive. So I don't even have to move anything to get rid of negative exponents because I don't have any. So this is actually my final answer. I don't have to do any more simplifying. All right, so here's how this works. Now that I've shown you how to do these, I want to give you some practice problems. So if you're watching this video, I want you to go ahead and pause it and work out numbers 1 through 7. And then whenever you're ready to check your answers, just play this video again and we'll go over the answers. Okay? Good luck. All right, so I'm going to go ahead and talk you through the answers now. So number 1, all we had to do was combine the exponents because the bases are the same. So when I do -10 plus 7, it gives me x to the -3, and then that needs to be moved down to the denominator in order to change the sign of the negative exponent to a positive. So our final answer is 1 over x cubed. Okay? On number 2, we have the same exponential base on top and bottom, so we can go ahead and subtract the exponents. So z to the 23 from the top minus 17 from the bottom leaves me with z to the 6th. I have positive exponents, so I just stop right there, and that's my answer. Okay. All right, number 3, I need to combine my x terms, right? So I can move this x term from the bottom up to the top, right? Or I can think about it as subtracting the bottom exponent, right? So x to the 3rd from the top minus the -12 from the bottom. And when we get double negatives, that becomes positive. So x to the 3 plus 12 gives me x to the 15. Again, I'm left with positive exponents. So that's my answer. We just stop there. Okay. All right. This one, I have more than one base inside my parentheses, which this exponent of 3 is being applied to. So I need to multiply that 3 times everything's exponent. Now this -1, I only have one copy of that, right? So it's kind of like I have an exponent of 1 right here on this -1. So when I do 3 times 1, I get -1 to the 3rd. When I do 3 times -2, that's going to give me a -6 in this exponent, right? Now, if I take -1 and I cube it, -1 times -1 times -1, that's still just -1. So I went ahead and simplified that here. And then my a to the -6 that we get from multiplying that one's exponents, I don't want to be left with a negative. Now, notice only the a to the -6 has a negative exponent. The -1 is fine. So I'm going to leave the -1 on the top, and the a to the -6 gets sent down across the fraction line to the denominator so that its exponent will become positive. Okay. All right, halfway there. All right, number 5. Again, there's nothing I can do to simplify what's inside these parentheses, so I'm going to go ahead and just distribute that -1. -1 times 2 gives me a to the -2. -1 times -1 gives me b to the +1. And when I distribute the -1 to the c, I get c to the -3. Okay, The two terms that have negative exponents need to be moved across the fraction line. So the a goes down, the c comes up, which leaves me with bc cubed all over a squared. Okay. All right. Number 6, we have distributing this 4 to everything inside the parentheses. Notice I showed the intermediate term, but when I'm talking through it, I'm just going to obviously talk through the answer. So x to the 4th times 4 gives me x to the 16th. When I apply the 4 to my 2, I end up with 2 to the 4th power, right? Which when I simplify that gives me 16. And then when I distribute that 4 to the negative 3, I end up with y to the negative 12. I don't want to have negative exponents in my answer, so I need to move that up to the top. So my final answer is x to the 16th, y to the 12th, all over 16. Okay. All right, and then the last one, I'm sorry, mine's marked out, but I wrote in the problem that you probably have on your notes. This is my first attempt, so I might have some edits throughout these videos, so I apologize for that. So this is our problem we started with. We want to go ahead and multiply straight across. So we get negative 15u to the 7th, v to the 12th, all over u to the 14th, v squared. And then because we have u's on top and bottom and v's on top and bottom, we can subtract those exponents, which will give us negative 15u to the negative 7, v to the 10th. And then just like the other ones, don't forget to move your ones with the negative exponents across the fraction line. So when we move this across the fraction line, it ends up on the bottom with a positive 7 exponent. All right, so that is the end of this first little part. So you now should be able to complete in your Knewton assignment listing both properties of exponents and advanced properties of exponents. Okay, if you have any questions, feel free to let me know.